Judith and I first met about 5 years ago, but this is the first time we've stood on stage together to give a presentation. So we'll probably start interrupting each other. It might not be slick, but it will be from the heart. And when we first did start collaborating back in 2007, we quickly realized we had a common pursuit in trying to understand the evolving concept of sustainability, a concept which I think is still evolving, and somehow try to frame what is a very large and complex subject, and that challenge continues to this day.
In fact, a number of consultant partners, that you'll see the logos, Hilson Moran and WSP as well. We've been collaborating on a number of tall buildings in the past. One of these you'll see projected up there on the left, which is EDIC, the Abar Towers in Abu Dhabi. We all have a long-running background on tall building design, and what we tend to find is that the most interesting and the most contentious areas are always where the disciplines overlap, and that often the best way not to be on the back foot when important decisions are made about long-term value is to do some of this research up front. So on timescales, you don't have the options to investigate enough alternatives.
Okay, the study that we're going to outline this afternoon really started about 2010, when we were set a challenge by Sir Stuart Lipton, who's a renowned developer in the UK, who wanted us to come up with a 40-storey office building in central London for something like half the cost of what most of those landmark buildings were coming out at. And at the same time, he said, I want you to also create something which is truly sustainable, and I'll leave you to decide what that means or what that might mean. And 8 or 9 months of intense work later, and we completed the study, and hopefully we'll give you a flavour of some of the key conclusions that we reached. And to a certain degree, it's sort of the starting point rather than a conclusion. It did actually create a bit of a stir in the press. It prompted quite a bit of discussion and debate about the appropriateness of icons, the value of icons, and perhaps more importantly, what tenants need and want. So the starting point, really, as I said, it was a 40-storey office building in central London. It was based on the British Council for Offices specification, 60-year lifespan. I won't read the whole of that. So the initial challenge was very much a financial one, but really perhaps the most important results of the study were about planet, carbon, but even perhaps more importantly than that was the impacts of buildings on people. Those occupiers that actually use those structures. And to put the financial challenge in context to begin with, I'm sorry this is in sterling and square feet, but that doesn't matter. It's the relative figures which will give you a flavour of the challenge. There's a large range of costs for tall buildings in London, anything between just less than £200 a square foot to way over £300 a square foot. It can go up to about $350, which is about $5,000 a square metre. So it's an expensive place to build, particularly high rise. And he wanted us to halve that. He wanted something which was about £125 a square foot. So that was our starting point. And the context, really, this is a very busy graph. I think all you need to understand from this is that the actual bars which form the top of that diagram are the total cost of an office building in London, and as you go from left to right on the scale, that's the increase in height. The important line is the purple line which zigzags along the bottom, and that is the height. So one of the key conclusions from that is actually there's little correlation between the cost of an office building and its height. There are other factors which have a much more important part to play, not least of which is shape and specification. So these are some of the projects which are either recently completed or in various stages of development in London. And as I said, there's a large range of potential costs. These are not in order of costs. And one of the challenges I have set people over the last 5 years is to try and place those in order of cost. No one has ever got that right, simply because they always think height is correlated to cost. So they always put the Shard on the right-hand side. The Shard is not the most expensive building by a long way in that line of projects, simply because its tapering form actually creates a very effective solution across structures and other elements as well. During the study, we're also keen to try and learn lessons from around the world. As you can imagine, there's a large range of costs globally too. Some of that is down to labour costs, some of that is down to other factors, but again, shape plays a large part of that. Even in London, where you've got the fat functional towers of Canary Wharf in the Docklands area to the east of the city, very, very different cost profiles to the more articulated landmark forms in the centre of town. I've been showing this slide for probably 7 or 8 years, and it's my favourite slide. I haven't changed it, I haven't updated it, but basically it's a very key point I'm trying to make here related to shape. Those figures on the left are wall to floor ratio. So that's the amount of external wall you get for every unit of floor area. So 0.3 is actually pretty good. That means for every 100 square metres of floor area, you have 30 square metres of external wall. So those Asian buildings along the top, although architecturally very interesting, iconic structures, perform very well in terms of that metric. Whereas along the bottom, those selection of London buildings don't. Most of those are 0.5, 0.6. So to a large degree, some of those, before you even start thinking about the specification of facades, have double the quantity of the facades, and that can affect the bottom line by over 10%. One of the reasons for that, and this is not to scale, is that those buildings in the Far East enjoy regular forms. They're larger floor plates with central concrete cores generally. They were at the time anyway. And those floor plates are extruded vertically. So there is repetition in form. Whereas in London, there's a whole array of engineering and architectural solutions, sizes of floor plates, configuration of floor plates, location of cores. And wall-to-floor ratio has an absolutely fundamental effect on cost, but also on efficiencies as well. So it's a double whammy if you've got a high wall-to-floor ratio. But if you can get both a cost-effective facade married to a simple tall building form, then you're doing pretty well. So if you look at those figures on the right, you get both of those right, then you can be 2.5 times, or if you get both of those wrong, you're 2.5 times more expensive than a simple cost-effective form. This is sort of trying to demonstrate the theoretical change in fundamental structural systems at different height thresholds. So starting with a very simple steel moment frame on the left, going all the way through outriggers, brace solutions, bundled tubes to the right. And that is a section through the Shard at London Bridge in London. Over 300 metres, that should be at least halfway along that graph, maybe slightly to the right. Actually, it's a very, very simple structural solution in relative terms. It's got a very large central concrete core which copes with most of the lateral wind loads, and therefore it enables it to have a pretty simple steel frame around it. You then compare that to the Leadenhall building, which is a very different approach for good reason, for different reasons, but that's a relatively complex exterior megaframe. It's expensive and it's quite involved, but it does create a large, impressive office floor plate with few columns. It also enables quite a nice interaction at the base with the public realm surrounding it. So there's a value equation there too. So after 8 or 9 months, these were the forms that we came up with as being perhaps the optimized floor plates for this challenge that Sir Stuart set us.
So In the process of this cost evaluation, what we realized that we're actually creating a baseline building. So it's not a design. It's a form of optioneering and being able to make comparisons on a quantitative basis, which we really we don't really do that often. Not in this speed and these amounts of options normally. We did opt for the the rectangular floor plate in the end, with the square floor plate, and double-decker lifts, curtain wall facade, long span steel building, and at that point we were asking, well, okay, but how sustainable is this option now, which is
yeah, so from a cost perspective, just you remember that challenge I set in one of the earlier slides, £250 a square foot. Frankly, I didn't think we had a chance of getting anywhere near to it, but we did. We got to about £140 a square foot. So in London terms, actually, that's pretty good for a low-rise building, let alone a high-rise building. And it was really the structures and the facades where the money just fell out of the equation. And then that had a consequent effect on costs such as main contractors, preliminaries, contingencies, and overheads and profit, because we were simplifying a building, we were de-risking it. So what's interesting about that is that then when you look at the new baseline scheme, what that does do is increase the relative importance of MEP services systems.
And the systems that we ended up evaluating against one another was the curtain wall versus the concrete precast facade, the long span steel, long span concrete with downstand beams, the post tension concrete versus the short span steel. The MEP systems were the VAV system versus the fan coil, the chilled beam, and then centralized versus decentralized. And just to give you the idea, this type of evaluation is not necessarily that straightforward, because once you look at all the options against one another, you have quite a few to evaluate. But we did do all of this work, and some of the conclusions were really quite interesting. Many people in my practice have asked me about, well, why did we opt for the double-decker lift? Well, actually, in London, double-decker lifts are pretty much mainstream solutions. And the reason is that the core saving, you can save up to 50% on core size. And the main concern is, well, what happens if the doors open above you and you're in the lift car below. But actually, typically less than 5% of all stops are those where only one deck is serving. And here are some international examples of double-decker lifts used. Long discussion about the steel versus concrete. And clearly steel is the knee-jerk response from most designers and developers, because it's long span. In terms of adaptability, it's really great. You can cut holes in the floor plate with no penalties. It offers a column-free space. However, there are issues with the recyclability, in particular when it comes to the fireproofing of steel structures. Some of these are more or less make recycling more or less difficult. In particular, as I got the lesson in the other evening about fireproofing, the old epoxy-style systems make recycling particularly difficult, whereas there are some new water-based systems, thanks for the tip, that make it much easier. In terms of concrete, clearly the shorter span is a bit of an issue. In order to make it more adaptable, you have to identify up front the areas where you might want to make openings in the floor plate. You get columns, although you can design some of them in a way that they don't obstruct the view too much. But the lifespan is very long. You design a tall concrete building, it's going to be there for a long time. And what was the most remarkable about it is that when you do the post-tensioning, you actually get shorter floor-to-floor heights. So for the same number of floors, you can do for a lot less height, which then ends up saving quite a bit on the facade costs. I just flagged up the details of one of these evaluation matrices. So we've done this type of evaluation for every single component. So looking at occupant comfort, adaptability, efficiency, resource use in construction, maintenance, and whole life resource use. The most important whole life aspect of structures is that they do contribute to, 15 to 25% of the capital cost, but 50 to 75% of the embodied carbon. It is the longest lifespan component. So the adaptability is more important in that sense for structures than for anything else. In terms of cores, it does seem that when you've got a central core building, the most commonly used cores these days are concrete. They are dominant up to 40 stories. Above that, there are steel gets introduced. But the main reason for that is the fire, so the stability that offers and the fireproofing. We've seen what happened in 9/11 with the World Trade Center towers. Composite cores are also often used where efficiency is really of the essence. Looking at curtain walls versus precast facades, clearly the main advantage of curtain walls in capital cost terms is that, or capital terms, is the efficiency. So it offers much up to a 2 to 3% gain on the floor area, net area. So it is the most obvious solution for most developers. Then there are the advantages of daylighting and other aspects. However, I think many of the other speakers have elaborated on this. In terms of solar gain and glare, they do present some challenges, which then cost extra to mitigate. Precast facades tend to be craneage tends to be an issue. There is a great example in London of a precast facade, which is the Centre Point. We do wonder, or we did wonder during this study, whether these facades are going to become perhaps more prevalent in the future, where the heat gain in high-intensity office buildings may reduce due to equipment being more efficient in the future. We'll see what happens to that. External shading systems, I did want to just show this building, not just because we just won the CTBUh Innovation Award for it, but because it does demonstrate what you can do with external shading, in particular when it goes dynamic, and certainly for a cost. But what this does is, as the sun tracks around the facade, the shutters close, and this allowed us to specify highly transparent glazing. I'm sure you're aware in the Middle East, most of the highly glazed facades are either very dark or highly reflective, and all the lights tend to be on. But in this building, we hope that's not going to be the case. The evaluation of MEP systems, we actually ended up spending quite a lot of time on the MEP system, very uncharacteristic for architects, perhaps. But we realized that actually, once you are looking at a relatively low-cost building, MEP systems end up making up to a quarter of the capital cost of the building. And when you look at whole life cost, it's actually just air handling is around 60% of whole life cost, and if you take the additional replacement costs and fit out costs, it's around 80 to 90% of whole life costs. This is really a big number because whole life cost tends to outweigh capital cost by quite a large figure. In terms of ventilation systems, the prevalent systems in North America and in the Far East are VAV system, and that's got very good reasons. It's because it doesn't require any intrusion into tenant areas, and also it's got centralized maintenance, which means that it can be quite well controlled. It is the higher cost, so it's up to 15% cost uplift, and the efficiency of VAV systems is highly disputed, and in the UK it's actually very difficult. It's become very difficult to specify because it just wouldn't pass building regulations in most cases. Going on to fan coil systems, clearly it requires tenant space access. This is really the mainstream solution pretty much all over Europe. And and becoming more and more common or frequently specified elsewhere. It is a bit sensitive to maintenance, so skilled workforce is required to maintain it, but it does offer a great deal of flexibility and control, and it's probably the most efficient, one of the most efficient. Chilled beams are an alternative with a marginal cost uplift, but requires less access to tenant areas, and it also offers the potential for higher, taller ceilings and exposed ceilings, which are becoming de rigueur in some developments. Certainly, it does offer the flexibility to go for that type of fit out. And the mixed mode, I'm not sure if you've seen Anthony's publication on naturally ventilated tall buildings. I think it might be launched today or tomorrow. A CTBUh publication, but actually mixed mode building are relatively rare. The reason is that in capital cost terms, they not only require the MEP investment, but also the investment in creating openings in facades. But it does offer up to 8% savings on whole life costs, so approximately between 10 to 15% savings on carbon emissions over a building's lifetime. And with mixed mode buildings, occupants tend to accept more out-of-range environments, and Steve would say with some education.
Yes.
Do you want to say a few words about centralized, decentralized?
The decision to go centralized or decentralized tends to be a space one rather than a cost one. It costs more to have more units and to spread your plant, but here's a good example. I'm not going to comment on the architecture, I'll let you think about that yourselves, but this is Elizabeth House in Waterloo in London for planning at the moment. Here we went for a decentralized system simply because we had severe constraints below ground, and therefore to remove the interstitial plant room above ground actually created a lot of valuable lettable space. So there was a premium of several £1 million, but that was dwarfed by the increase in value. This is basically what we called the sustainability evaluation matrix, which summarized everything that we've talked about on this traffic light system, where red represents bad and green is good. I guess we've been given the 5-minute warning, so I'm going to speed up. I guess if there's one conclusion that came out of this, it was that depending on which perspective you were looking from, whether it was people, profit or planet, almost without fail, you got a different answer.
And you may ask how we define sustainability. I mean, you'll see the people, planet, and profit headings were actually broken down into each of these areas with, if you press the button, with the hard metrics on the right side and the soft metrics, which are a lot more subjective, on the left. And you've said it, but okay. Weighting is everything. So what you build in one location may not be the right thing in another location, and what works for one type of developer may not work for another one. So what this allowed us to do, actually, we've made all the calculations, we've gathered the data, and we are now in a position to weigh these up depending on the client, the location, and their preference, with a good understanding of what the long-term impacts of these decisions are.
So the soft metrics that Judith was talking about are certainly the most difficult to measure, but actually they have the greatest impact over the life of a building, and therefore we shouldn't shy away from attempting to measure and assess them. So for me, this is perhaps one area, certainly for further study at some point. And when you actually consider the impact that people have on an office building, as sort of Judith alluded to earlier, it dwarfs any consideration about capital costs. So over the 60-year life of an office building, 90 to 95% of its total cost is related to people, staff, salaries, and associated costs. This is quite interesting. This is very confidential and a few days old. David Roden, architects, lent me this. There is a very well-known bank in England which is actually starting to get interested about the principles that underpin this study. They're now encouraging us as a team to look at an office building which creates a different product, where we can actually start from a rational viewpoint, very simple, elegant but cost-effective facades, a very straightforward structural frame without complexity. And the money saved from some of those key elements we can either factor into a reduced rent, or we can reinvest that into the workplace, creating interesting spaces, double height spaces, and increased floor to ceiling height. So this system actually works on, it's actually a duplex office system that comes in units of 2 with a lightweight mezzanine structure between the 2, and it's creating quite a bit of interest. This is one of Judith's.
Works well with double deckers.
Yes, yeah.
This is a scheme we developed recently for number 1 New Oxford Street. A colleague of mine in Ida, Simon Bowden, led the project. What we did here is to increase the generic floor-to-floor height of the building to allow the building to be converted from residential to office and vice versa. The second thing we did was to make the floor plate shallower, which you would say, okay, but that becomes a grade B office space. Do tenants really mind? So in some ways this counts as a boutique office development, but the question is, will these take off in the future more? Just a very quick animation to show you that actually we built this study on the back of a previous study that we have done, which took many of these drivers and relationships and encompassed it in a parametric model. So you can effectively type in a net area and arrive to the right number of stories in the building, and have updates of the capital cost, the whole life costs, the operational carbon and the embodied carbon as you change the shape and height of the building.
The important thing being that you're assessing all of those things at the earliest design stage. So, final slide. When we finished the study, we actually took Peter Rees, who's the City Corporation's chief surveyor in London, through it. And in many ways, he's responsible for this developing skyline in central London, which has a number of icons and potential icons. Characterising it, and we asked some fundamental questions and had actually quite an interesting and lively debate about it. And these are just some of the key questions it prompts, and maybe we can leave that for the questions afterwards. We're done.
Thank you.